So let's look at how to compute some of these probabilities for the normal distribution. So first they want us to compute the area between z is negative 0.54 and 1.88. So we're going to do these all using the calculator, using the distribution menu, which is second variables. So now by default, mean is 0 and standard deviation is 1. So then the format of the normal distribution function, which is going to help us compute these, you put in lower bound, upper bound, mean, and standard deviation. So if mean is 0 and standard deviation is 1, then you can just put in lower bound, upper bound. That's for z values. So if mean, standard deviation are 0, 1, you can leave it. So here's a picture of our normal distribution. We've got a mean of 0 in the middle, and then 1, 2, 3 standard deviations to the right, 1, 2, 3 to the left, gives about 100% of the data. So negative 0.54 would be approximately right here. And then 1.88 would be about right here. And we want the area in the middle there. So we want that area right there. So our area here, we're going to use that normal CDF function. So that's our command. So anytime you use these for hand-in assignment, write down your calculator command. Our lower cutoff is negative 0.54. Our upper cutoff is 1.88. And then we put in our mean and standard deviation, 0, 1. So let's go to the calculator. So I do second variables. It gives me the distribution menu. We want number 2, normal CDF. By default, your lower cutoff is negative 1 times 10 to the 99 power times 10 to the 99, which is taking the place of negative infinity, because you can't put infinity into a calculator. Now for us, we want negative 0.54 to 1.88, so we'll change that to 0.54, and then we want 1.88, and then our mean here and standard deviation are 1, so we can just paste that. Now if you don't get the menu, just enter in your numbers here with commas between them, comma buttons right here, and then enter. So 6753. So this area here is 0.6753. We usually do 4 decimal places on areas. Okay, so try this one. Pause the video for just a second and then enter that into your calculator, see what you get for lower cutoff of negative 1.11, upper cutoff of positive 2. So that's going to be right here, negative 1.11 up to positive 2 right there. So it's this area in here that we want. Area corresponds to probability. So this one up here, we could write this as probability negative 0.54 is less than z is less than 1.88. So they could either ask you for area or they could ask you for probability. Those are equivalent statements. So try that one real quick. Okay, so if we go to the distribution menu, second variables, number 2, normal CDF. So we have a negative 1.11 up to a positive 2. Paste it, enter, you should get 8438. So this is normal CDF, negative 1.11, 1.88, or I'm sorry, that one's 2. 0 mean, 1 standard deviation. And we got 8438. So that area, 8438. And then the area between negative 1.11 and positive 2 with an equal sign instead of strictly less than, that is also 8438. So it doesn't matter when you're doing normal CDF if you've got less than or less than equal, the probability or the area is going to be the same, because the only thing you're adding is the area above negative 1.1 and the area above 2, but those are line segments. Line segments have no area. Part D, we want to do the probability Z is less than 2.35. So 2.35, so you got Z equals 0 in the middle. 1, 2, 2.35 about right here. And we want the area to the left. So we want all of that area there. So that's almost 100% of the area. So this is going to be the area left of 2.35. And so that's going to be normal CDF. And then our lower cutoff here would really be negative infinity, but we can't put infinity into the calculator, so use negative 10,000 should be enough. Your right cutoff, 2.35, and then mean standard deviation, 0.1. Let's enter that. So second variables, normal CDF, negative 10,000 up to 2.35, and paste it, enter, 9906. So that's the probability, and it's also the area. So areas are probabilities for the normal curve. And then here they want the right area. So the right area, so area to the right of negative 1.2, which is equivalent to saying probability that the z-score is greater than negative 1.2. So here's z equals 0 in the middle, negative 1 here, so negative 1.2 would be about right there. And then we want the right area, so we want that area there. So that is going to be normal CDF. And then we put in our lower cutoff, negative 1.2. And then our upper cutoff is really infinity because this curve keeps going, but we're going to just use a big positive number, 10,000. And then 0.1, mean standard deviation. So let's enter that in. Second variables, normal CDF. We are going from negative 1.2 to 10,000. 0.1 stay the same, paste it, enter, 8849. And so the probability and the area are both 0.8849. So that's finding the area from the z-score. We actually can do it the other way around also. So if you're given the area, go back and find the z-score. So for example, probability z greater than z0 is 0.05. So that's saying the area to the right of this z-score, z0, is 0.05. We want the z-score. So, well, that z-score's got to be way over here on the right. Let's put it right here, z0. And then this little sliver of area right there is 0.05. So that means that the area to the left here is 0.95. So 95% and 5%. So the function we use in the calculator is inverse norm, or inv norm, and you put in P is the area to the left of the z value, or x value, depending on what you're looking at, and then mean standard deviation. So that gives you x0, which is the x value with area P to the left. Now, if that's if you've got mean mu and standard deviation sigma. Now your default is 0 and 1. Those are z-scores. So for z-scores, you can just do inverse norm and put in your left area. And that'll give you the z-score. So our left area here is 0.95. So we want to do, so our z0 here is going to be inverse norm of 0.95. And then mean standard deviation R01. So let's compute that. So second variables, inverse norm number 3, our left area 0.95, 0 and 1 are all set. And then if you have a menu on the calculator and updated OS, it'll let you choose whether you're giving it the left area, center area, or right area. If you don't have the menu, by default, it's left area. So we will press enter to paste it, and then enter again, 1.645. So that's Z0, 1.645. And this is 1.645. Usually they use 2 decimals for z-scores, but sometimes 3 if it's close to being in the middle. Let's look at one last example. Probability that z is between z0 and its negative is 0.99. So that's saying the middle area is 0.99. So we've got some cutoff here, z0, and then it's negative down here, negative z0, and then this middle area is 0.99, 99% of the area. So that means that the area out here on the end here, the two ends, has to total 1%. So it's divided equally because symmetric, so this will actually be 0.01 divided by 2, 0.005. And then this is also 0.005. So that means that for z0, the left area is really 0.99 plus 0.005. So this is going to be inverse norm. And then our left area is 0.995. And then 0.1 mean standard deviation. So let's compute that. So I'm going to clear out here. Second variables, we want number 3, inverse norm, 0.995, and paste it, enter, 2.576. So this guy out here is 2.576, and this one is negative 2.576. Now, if you do have the menu where you can choose, you could do this. You could just say, well, my area is 0.99, and come down and change this to center. So the middle area 0.99, and enter, and then it tells you the negative and the positive, but that gave us the same values. If you don't have the menu, you got to do the left area. So a couple different ways to do that one.